Let's find the oxidation number for the carbon in C3O2. This is carbon suboxide. So as we look at this, we're going to find first the average oxidation number for each carbon here in C3O2. So we don't have a negative or positive after C3O2. That means it's a neutral compound. In a neutral compound, all the oxidation numbers, they add up to 0. We don't know what the carbon is. Let's call that X. And oxygen, that's going to be -2 with just a few exceptions here. So each oxygen, -2. And the whole thing, that adds up to 0. So we could say 3 times X, 3X minus 2 times 2, that equals 0. So 3X minus 4 equals 0. 3X equals a positive 4. And then we're going to divide both sides by 3. So we end up with X equals 4/3. And that's the average oxidation number for each carbon here in C3O2. But that's kind of strange. How do you have a fractional oxidation number? And here's why. We just calculated the average. But these carbons here, the one in the center, it's different from these ones on the end. So this carbon here, it's bonded only to carbon atoms. Because of that, there's no difference. The oxidation state is 0. For each oxygen, we know it to be -2. So the only way all of this is going to add up to 0, since it's a neutral compound, is if these carbons here are +2. So we have total +2 and +2, that's +4. So we have 3 carbon atoms, and the total oxidation state is +2 and +2. That gives us the 4 here, 4/3. So that's why we have a fractional oxidation state for C3O2, carbon suboxide. This is Dr. B, and thanks for watching.